Right, good evening, ladies and gentlemen. Welcome to 4 Hamilton Place for this lecture on behalf of the Aeronautical Heritage Specialist Group. I'm Howard Mason, chair of that group and former BAE Systems Heritage Manager, so I got to look after all the old stuff. That included me. Just some notices for the parish notices. There will not be a fire alarm test in the building today, therefore if the alarm sounds, it will be genuine. Please exit the building. The designated assembly point is out of the building, down the hill to the junction of Hamilton Place and Piccadilly, where there's a fenced area beyond the hotel. If anyone has mobility or access issues, please make yourself known to a member of the event staff there so that they can make arrangements. Do not leave unmarked bags or other items unattended. Please set your mobile phones to stun. The event is being recorded and will be put on YouTube afterwards. After the lecture, there's going to be an opportunity for questions. Please use the mic over here if you want to speak, because that way the question gets onto the recording. Anyway, that's enough of me for tonight, so I'm going to hand over to your Master of Ceremonies for this evening, Dr. Robert Hopkins, who also happens to be the editor of the Journal of Aeronautical History. So he's responsible for all the learned papers that are put up on the website covering definitive heritage information. So, Robert, over to you.
Thank you. Good evening, everyone. To ensure that Paul has an audience throughout the presentation, at the end, you all have those wonderful little tickets, and we'll have a drawing for 2 copies of Paul's brand new magnum opus on the SR-71. So if you plan to leave early, you won't be around to benefit from that, but please keep your tickets, and at the end of the presentation, after Q&A, we'll have the opportunity to draw 2 lucky winners. And if you wish, if you're not among those 2, Paul will be available for signing and purchase of his book afterwards. You may have seen the display up in the main lobby. So keep that in mind. And if you aren't aware, the book weighs, 6 kilograms? So you may need a lorry to get it out of the building. You know, there have been 660 Americans who have trained as astronauts and gone into space. Fewer than a third of that number, 178 men and 1 woman, have trained as crew members for the Lockheed A-12, YF-12, and SR-71. This elite group has flown some of the most classified missions in the world in the reconnaissance area, and the crew members have flown an airplane that, well, until recently, even the flight manual was almost fully classified. There's still parts on the defensive system that remain classified. When I talk to these crew members, they all say the same thing. Robert, we went to places, we did things that we couldn't even tell our wives. Fortunately for the world, this elite group has chosen tonight's guest speaker to be their unofficial historian. And it's not surprising. Paul has written multiple books on the Blackbird and is considered widely as perhaps the world's most authoritative author and researcher and historian on this extraordinary airplane and its missions. We are extremely fortunate tonight to finally hear what they told Paul but wouldn't tell their wives. So please join me in a warm welcome for Mr. Paul Crickmore.
Soviet threat to the United States required a strategic reconnaissance collection capability. In October of 1954, President Eisenhower accepted recommendations by his Blue Ribbon panel to use aerial collection to gather strategic reconnaissance using covert overflights, controversially to be flown by civilian CIA, not US Air Force pilots. Eisenhower approved the first U-2 overflight of the Soviet Union on the 4th of July 1956. It was flown by CIA pilot Hervey Stockman. The image that the airplane returned was absolutely unbelievable. The resolution of the imagery was something never before seen. The problem was that the airplane had been tracked throughout by Soviet radar, and indeed attempts were made to shoot this subsonic intruder down. In response, the very next month, August of '56, radar camouflaging proposals and methods were explored in an effort to reduce the U-2's radar signature. The project was codenamed Rainbow, but it ultimately failed. And in January 1958, the CIA tasked Skunk Works boss, Kelly Johnson, and his team to go ahead and design a U-2 replacement. The new program was called Gusto, and here we see a stealthy subsonic example of this particular airplane, and this is the Gusto Model 2A. In April 1958, Johnson, however, became increasingly focused at placing extreme speed and altitude performance at the heart of vehicle survivability. And at this stage, actually, stealth was almost of secondary consideration to him. Now here we see quite a graphical effect, the way that extreme speed and altitude, when combined, will reduce the engagement window when confronted by an SA-2 threat, thereby creating a survivable platform. The SA-2 launch crew, with the aeroplane cruising at 80,000 foot and Mach 3.2, had just a 10-second firing window from the maximum detection range of the Fansong radar to the minimal missile range. So the parameters were incredibly tight. On the 21st of April, 1958, Johnson drew up his first Archangel proposal. This was for a Mach 3 cruise aircraft with a range of 4,000 nautical miles and an altitude performance of between 90 and 95,000 feet. Over the next 20 months, many design iterations and sub-iterations were evaluated, and they varied not just in shape and size, but also different engine configurations. They were designated A1 through A12. And here we see the A1 design, the A3, the A5, and the A12. And you can see how they really do differ quite dramatically from one another. As an aside, Archangel, the name, is a bit of a throwback to the U-2 days. When Kelly's design team were working on the U-2, because of its amazing altitude performance, they called it in-house Kelly's Angel. Well, this fella was going to fly quite a few thousand feet above that, and so they began calling it the Archangel. While U-2 design replacements were being drawn up and evaluated in the United States, U-2 overflights of the Soviet Union continued. However, aircraft vulnerability was demonstrated in dramatic form on the 1st of May 1960, when Frank Powers was shot down by an SA-2 during a Soviet overflight. The incident terminated US manned reconnaissance over the Soviet Union, and it also put a question mark over the building of a U-2 replacement. And here we actually do see a picture of the man himself, Gary Powers. 8 months before Powers was shot down, Lockheed A-12 design had beaten rival designs from Convair, and Lockheed were awarded a contract from the CIA to build 12 A-12 single-seat airplanes and 1 two-seat trainer. The code name for this program was Oxcart. It was John Parangowski, who was the CIA program manager, who selected the name from a random list of code words. He thought it quite ironic to actually call it what developed into the world's fastest operational jet, after what was one of the world's slowest forms of transport. Appealed to his rather wry sense of humor. And so, on the 25th of April, 1962, the A-12 first took to the air from Area 51, and at the controls was Lockheed Chief Test Pilot Lou Schock. The Oxcart had been flying for about 6 months when on the 27th of October 1962, during the Cuban Missile Crisis, U-2 vulnerability again was highlighted, and this time US Air Force pilot Major Rudolph Anderson was shot down and killed. By mid-1964, the A-12 had demonstrated its speed, altitude, and endurance capability. 4 of the 13 airplanes up at Area 51 had been designated to collect strategic reconnaissance from over Cuba. The program was codenamed Skylark. However, this proposal was rejected due to bureaucratic infighting, really, between the Joint Chiefs of Staff, the Secretary of Defense, Robert McNamara, Secretary of State Vance, and the DCI, McCone. They objected on the basis that actually it could compromise overall Oxcart secrecy. But in 1966, rumors started to wander around the US intelligence community that the Soviets had supplied Scud and Shaduk missiles to the North Vietnamese. If correct, this actually was of significant threat, strategic threat, to US military forces who at the time were building up in South Vietnam. The Lookout Task Force identified 4 areas in Vietnam where surface-to-surface missiles might be hidden and launched from. However, much of this area fell within high-threat areas of North Vietnam. The existing platforms that would be called upon to verify the existence of these missiles were proving vulnerable. The U-2, as we've seen earlier, to SA-2 attack, the RF-101, the RF-4C, and the high-level Buffalo reconnaissance drones were actually vulnerable to both SA-2 and AAA fire. So what to do next? Well, at this time the US were expanding their satellite reconnaissance capability in a program codenamed Corona. Here you see the KH-4, Keyhole 4 satellite. It acquired panoramic imagery, but with a spatial resolution of between 6 to 24 foot. It was incapable of differentiating between different missile types. Here, the KH-7 was a high-resolution satellite. The problem was it was constrained by the number of targets that it could image on a single mission. But overriding all of these considerations were the fact that both actually were needed to fill in the reconnaissance gap of the Soviet Union following the shoot-down of Gary Powers. So, there it was. Oxcart was the solution. And it was deemed that Kadena on the island of Okinawa would be the ideal base from which to fly operations. Consequently, support facilities were prepared in readiness for the deployment. So here we can actually see 2 pairs of hangars set either side of the operations and support buildings. And then these 2 fuel tanks here were built to house the PF-1, later known as JP-7, special fuel for the aircraft. Excuse me. Trans-Pacific deployment of the Oxcarts from Area 51 began on the 22nd of May 1967. Malvorodich was the first off in Article 131. The flight, as you can see here, got airborne, air refueled off the coast of California before accelerating, climbing to height and speed before descending for a second air refueling just off of Hickam, Hawaii, Hickam Air Force Base, Hawaii. Again, climb, accelerate, decelerate, then down for a third air refueling from Wake Island before carrying on to Kadena. Had there been a problem at Kadena, then the diversion base would have been Kunsan in South Korea. The flight took just 6 hours and 10 minutes. And it actually was a new world speed record from the United States to Japan. But of course, it couldn't be registered for security considerations. But 2 days later, Jack Layton flew Article 127 on the same route. And then on the 26th, Jack Weeks followed in Article 129. Deployment to Kadena heralded basically the de facto public debut of Oxcart. And on the 29th of May, the DET was declared ready for operations. Operation Black Shield was about to begin. Malvorodich was the first pilot to fly a Black Shield mission. This, however, was far from his first venture into hostile airspace. Back in 1953, during the Korean War, he'd flown multiple clandestine sorties in the RF-86 reconnaissance deep into Red China. And on one particular mission, he photographed the Sup-Yung Dam, which was between North Korea and the Communist Chinese mainland. During that operation, he was attacked multiple times by MiG-15s. He was unable to punch off his so-called drop tanks, but managed to stay ahead of the pack, and landing back, the tape was downloaded, giving the information to the PIs that they needed, the photo interpreters that they needed. It was an action for which he was awarded the Distinguished Service Cross, the DSC, which is the second highest gallantry medal in the United States Armed Forces. So, Vorovodich's first mission was flown on the 31st of May, 1967, and flown in Article 131. In total, he spent 9 minutes flying across what was called denied airspace, which of course wasn't over North Vietnam. There was no reaction from the North Vietnamese air defense system. Clearing the area, he descended over Thailand into an air refueling track, which is known as Scope Pearl. Following filling up tanks, he accelerated again and climbed, exiting over the demilitarized zone before recovering into Kadena. The mission was certainly a success, but it did not reveal any surface-to-surface missiles. What it did, however, was image 70 of the known 190 SAM sites in North Vietnam. This was going to happen. Okay, so imagery taken during Black Shield is extremely rare. I was very, very lucky to discover this little gem. I will apologize ahead of time for the quality. It looks like something that was filmed during the Wright brothers' times. and it's filmed in slow-mo. What you'll see as the aeroplane passes you, or what you won't see, are any national insignia. And as for the spotters amongst you, the code on the tail, 77258, completely bogus. Sorry, it hasn't got the sound of those beautiful engines to accompany it. Like the U-2 before it, Oxcart had a limited electronic intelligence, or ELINT, gathering capability. However, it was primarily a platform from which to gather photographic intelligence, or photint. At the heart of the sensor system was the Perkins and Elmer Type 1 panoramic camera. Equipped with an 18-inch focal length lens, it imaged onto very specially developed fine-grained film, enabling it to be enlarged many, many times over to extract incredible detail. The camera was palletized and was located in a compartment here. Whoopsie, let's go back a bit. Yeah, that's what I need. It was located in a compartment behind the cockpit known as the Q bay. When the aeroplane landed and the camera was removed, the film was flown by special courier to the Kodak processing plant at Rochester, New York. Once processed, the film was then taken to the National Photographic Interpretation Center, NPIC, which was located inside the Naval Dockyard at Washington, D.C. There, the imagery was analyzed closely by photo interpreters. Intelligence reports were drawn up and then distributed to those that were cleared to see it. This whole exercise was speeded up quite considerably after Black Shield's 10th mission, when films were also sent to the 67th Reconnaissance Technical Squadron, which was based at Yokota Air Base in Japan. This meant that actually intelligence generated by Oxcart was in the hands of theatre commanders within 24 hours of an Oxcart landing, which at the time was something quite unheard of. The camera system consisted of a forward and aft scanning system. The forward camera actually scanned the Earth 21 degrees to the right of track, going out to 67 degrees to the left. The camera behind it scanned from 21 degrees left to 67 degrees right. That generated a get the hang of this in a minute. This generated a 42-degree stereo overlap directly below the aeroplane. Excuse me. To aid photographers when it came to analyzing where the aeroplane was when the images were taken, there was a data block at the end of every frame, at the far edge of every frame. And here we see a latitude and longitude of the aircraft when the image was taken. Underneath was a block about the mission itself. This was BX, Black Shield, BX 6719. The time underneath, displayed on a very accurate Bulliver watch clock, showed 2 a.m., and that was GMT, so that was 8 o'clock local time in Vietnam. The lat and long of the aeroplane actually put it just to the south of Hanoi. Ground speed below was displayed in knots. The digit here was never displayed, which actually was a 1. So this aeroplane at the time this image was taken was flying at 1,862 knots. That's about 2,250 miles an hour. This here is the film strip that the PI, the photo interpreters, would see. And you can see here the data block at the far edge of the film. The swathe that these cameras was cut from 80,000 foot was 36 miles either side of the aeroplane's track. The resolution at nadir, that's directly below the aeroplane, was about a foot, pulling out to about 3 to 4 foot at the edges of the frame. Jack Layton was third up, and he flew mission BX 6705 on the 20th of June 1967. These images of the maps that you see here are actually from the CIA. These were actually put together as part of the history package, which remained classified for many, many years. And so it's quite significant. This sortie was flown by, as I say, Layton, and it involved making 2 passes over what they called the denied area. First pass up and across, air refueling. Second pass up and round over the Gulf, and then along here. Now you'll see this red line, and that denotes the radar tracking. And this was the first flight that the Chinese communists, the Chi-Coms, were actually able to detect and, for a very short period of time, track the aeroplane. But you'll notice, look, the track jitter compared to the actual ground track of the aeroplane. But a good starter for 10. Again, no sign was found of surface-to-surface missiles. However, this flight imaged 133 of the now 200 SAM sites, of which 20 were occupied by SAM missiles. The SAM battalion was extremely mobile. It took just 3 hours to dismantle the radar, the launchers, and everything else, and get them ready to move off. It took then another 6 hours to erect the site. At the time, there were about 6 sites per SAM battalion. This enabled the North Vietnamese to play a game of cat and mouse with the US strike planners, moving missiles from site to site. Black Shield imagery therefore became increasingly focused on gathering tactical reconnaissance of the SAM threat, rather than strategic reconnaissance for which it was originally designed. And this really is a classic case of mission creep. Essential to all Black Shield missions was the specialized support that the KC-135Qs provided. They were always there, bang on where and when they were needed. SAC, however, never acknowledged its participation in the program. Interagency collaboration from a variety of sources included the National Security Agency, the NSA, and they provided communications intelligence, comment. And this revealed how the North Vietnamese and the Chi-Com Air Defense Network was reacting to Black Shield missions. Excuse me. On the other side of the fence, a comment provided by the NSA verified the level of collaboration that was going on between the North Vietnamese, the Chi-Coms, and their Soviet advisors to track Black Shield missions and then to use that information for potential targeting. So aware of the level of this cooperation going on from comment that was drawn by the NSA, the CIA decided that they would put together a mission to try and confuse the tracking that was going on. And again, we can see, look now, how this tracking in red, was getting tighter and tighter and prolonged against the ground track of the aircraft. So, BX 6710 was flown by Ken Collins in Article 127 on the 20th of July 1967. First thing that you'll see along here, this dotted blue line, is Church Door. So Church Door was a covert mission supported by the CIA and flown by the Republic of China Air Force in U-2s out of Taiwan. And here, the tracks crossed at 11:47 local. The U-2 continuing north over Hainan Island and penetrating into the south of China, into southern China, whereas the A-12 continued round Hainan Island and then penetrated North Vietnam. So then, coming up to the second pass, having it air refueled, we have a high-altitude reconnaissance drone participating in Blue Springs, the mission being BSQ 190V638, tracking south as the Oxcart flew out over the Gulf of Tonkin. And again, tracks crossed with the drone going underneath the Oxcart at 1307. To say, the whole idea was to try and confuse the tracking that was going on. It was spectacularly unsuccessful. In fact, it just highlighted basically that there was a lot of high-level activity that was going on. So these tactics were never again repeated. On the positive side, by this time Black Shield had been in operation for 2 months and almost completely covered the surface-to-surface missile search area. And NPIC were about 80% confident to state that there were no surface-to-surface missiles in North Vietnam. To expedite the vital position information about Black Shield, which was required within the North Vietnamese and the CHICOM integrated air defense system, a top priority messaging system was developed. This cut down transfer times from 6 to between 1 and 3 minutes. This gave the SAM battalions more time to prepare for a possible engagement. Now, when your target is flying at 3 miles every 4 seconds, these sort of numbers are potential game changers. The Soviet friends undertook a number of modifications, field modifications, not only to the SA-2, but also to the Fansong radar in an attempt to degrade Oxcart's defense electronic, or DEF, system. One of the changes were to the warhead detonation fuse, having discovered that it was being triggered prematurely. Another involved launching the Fansong radar in a low pulse repetition frequency mode for 6 seconds, and then switching into high PRF mode for final guidance of the missile. Now, this increased the range of the missile compared to those that were fired in high PRF throughout the engagement, thereby increasing the target window. The range extension came only with minor degradation to the missile's capability brought about by the initial low data transfer rate. The 16th Black Shield mission, BX-6732, flown on the 28th of October 1967, was flown by Denny Sullivan in Article 131. This was the first time that the North Vietnamese actually fired an SA-2, fired an SA-2 at an Oxcart on the second pass. It missed its target, and actually comment received intercepts, captured intercepts of the regimental controller being berated by the SAM battalion controller for launching late. Following, now we've got 4 images taken from an actual attack on an Oxcart. So this is, as we saw earlier, the full strip, and this would be from the second camera going from the left out to the right, so we have about a 36-mile swathe there. again, you can see the data block on the edge of the film. And I just remember that meandering river at the top there. So this is the sort of thing that the PIs would see and then start to dig deep and look down to see what was going on. So going in closer, here's the data block. This is the frame number, 0502. No foreign dissemination. This imagery was invaluable and was not to be seen by anyone outside of the United States. And of course, they obviously had to have some of the highest security clearances to have access to it. So the meandering river, and let's look now on the far bank there. You might be able to see a little something that might be quite interesting. So again, the PIs would pull in closer, and bang, there we have it. It's an SA-2 launch from a SAM site. Looking around that frame closer, and there it is. The SA-2 that's actually being fired at the aeroplane taking the picture. It's one for the photo album, isn't it? So 2 days later, the North Vietnamese were so focused on wanting to down one of these wretched airplanes that they redeployed 2 SAM battalions from the area of Haiphong to boost the defensive systems around Hanoi. Facing this, unbeknownst to him, was the same pilot that had a missile fired at him 2 days earlier, Denny Sullivan. Again, we can see, look, how that track is being, is being followed. Whoopsie daisy, that will spoil it, won't it? How the track was being followed by the radar tracking. And now look on that second pass, against the mantra of reconnaissance of one pass, then haul arse. Oh no, we have a long, straight-in approach over the same target area. Not surprisingly, the North Vietnamese, or the children of the dragon as they call themselves, were waiting. And so began the salvo launching. Between 7 and 10 SA-2s were fired at that aeroplane from 6 sites. This is Adam Tooby's artist impression of that intense barrage. And you really do get an idea of what the heck it must have been like, with an SA-2 exploding just behind the aeroplane and a couple more SA-2s coming up to the right-hand corner. I mean, they really did come extremely close to bagging the prize. This is quite a busy graphic, so I do apologize ahead of time, but it was generated, again, by the CIA and formed part of their post-mission analysis. It shows the DEF system in operation during the missile attack. The aim of that missile attack was to actually swamp the DEF system, allowing 1 or 2 missiles to get through it and take out the target. The whole event took just 55 seconds, and it's believed to be the largest SA-2 barrage that was fired at on a single aircraft. And we've got a couple of quite interesting little bits and pieces down here in the key. So the first one is one of the electronic little black boxes. It's called Blue Dog. Blue Dog actually generated false radar returns into the Fansong radar to confuse the guidance radar. And then underneath we have Mad Moth. And Mad Moth actually provided angle deception, again, that was aimed at the Fansong radar. None of the warheads hit the target. However, 2 tiny pieces of shrapnel caused minor damage to one of the wing fillet supports, seen here. And this is actually on display at the CIA Museum headquarters in Langley. Therefore challenges the myth, actually, that no Blackbird was ever hit by a missile. So So after a thorough analysis and regrouping, subsequent Black Shield sorties were flown at 86,000 foot. That's 4,000 foot higher than previous sorties. During this mission here, BX-6842, flown on the 4th of January 68, you can see how the guys weren't really on top of their game with the radar tracking some distance off the tracking of the aeroplane. As a consequence, the single SA-2 that was fired at Article 127 that was flown by Jack Layton was fired late and beyond range and came really nowhere near to hitting the target. The 23rd January 1968 seizure of the US Navy intelligence gathering ship Pueblo by the North Koreans put focus back for Black Shield from gathering tactical reconnaissance to gathering strategic reconnaissance. And Jack Weeks was the guy that was scheduled to fly the sortie. So on the 26th of January 1968, just 3 days after the ship was seized, BX-6847 was flown in Article 131. Its mission was plain and simple: find Pueblo and establish if North Korea were about to embark on a ground action against its southern neighbor. Both tasks were of immense importance, strategic importance to the United States. And 3 passes were made, as we can see here, over the totalitarian state. The combined times of those 3 passes, 15 minutes. Pueblo was found in Wonsan Bay, and imagery ascertained that the North were not making preparations to invade the South. And this rather demonstrates the quick response time that's possible with a manned reconnaissance platform compared to that of satellites. And unfortunately, that to a degree remains the case even today. There were 2 other missions over North Korea, and they were actually pretty much the swan song of Black Shield. And following the termination of Oxcart, the 2 remaining A-12s were flown to Palmdale. Unfortunately and tragically, Article 129, flown by Jack Weeks, was participating in a routine functional check flight when they believed there was an enormous structural failure. The aeroplane completely disintegrated, and there was never a trace found either of Jack Weeks's body or any wreckage at all. It's believed to have happened about 120 miles north of the Philippines. The remaining 6 aircraft at Area 51 were also positioned down to Palmdale. And you'll notice here, yet again, this is a Black Shield airplane. It has a bogus serial number in red, 77835. The map here was used by Frank Murray, and he flew the last A-12 out of Area 51 and down into Palmdale. This repositioning and moving aeroplanes into Palmdale was called, as you see from the bottom right there, Scope Barn. The CIA recognized the heroism of those that participated in Black Shield, awarding them each their highest medal for gallantry, the CIA Star for Valor. Jack Weeks's widow took his award. He was posthumously awarded it. And here we see Admiral Rufus Taylor, who at that time was Deputy Director of CIA, making the awards. Due to the highly classified nature of Black Shield and indeed Oxcart, these pilots went largely unrecognized for the true pioneering achievements that they made and contributions to strategic reconnaissance. In 1968, the SR-71 replaced the A-12, conducting missions over North Vietnam and global strategic reconnaissance. So, lessons learned. Well, the real big one was the requirement for a high-resolution radar, an HRR. This would enable targets to be imaged through cloud, something that Oxcart was unable to do. Langley was hoping to schedule the aeroplane to fly 9 missions a month. Most of these, however, were cancelled. The monsoon rains, the cloud cover, etc. So in the 12 months that Oxcart was operating, only 29 missions were flown. That gives an average of about 2.4 a month. Equipping, however, the HRR, the SR-71 with an HRR, its capability increased exponentially, enabling it to gather simultaneous synoptic coverage of a target area. Revised Oxcart procedures were crucial to SR-71 operations in North Vietnam, beginning with the first mission flown by the SR-71 out of Kadena on the 21st of March 1968. It was flown by Jerry O'Malley and his backseater Ed Payne, and it incorporated the use of HRR on that very first sortie, which was flown just 2 weeks after Oxcart's last foray over North Vietnam. 20 years after Eisenhower decreed that all US covert strategic aerial reconnaissance would be conducted by civilian CIA pilots, the mission was transferred exclusively to military pilots in SAC, Strategic Air Command. There's no doubt that SR-71 crews were some of the best in the Air Force, but I know for a fact that most of them would agree when I say that they stood on the shoulder of giants. Ladies and gentlemen, thank you very much for your time, and I'd like to open up the floor to questions.
Ladies and gentlemen, Leah here has portable microphones. You don't need to get up and wander around. If you have questions, I'd be happy to hear from you. All those answers I can feel. At any rate, if you have questions, feel free to raise your hand and get started. Yes, sir, right here. Thank you for your patience to get the microphone to you. As you heard, we're recording this.
Thanks so much. It was an absolutely awesome presentation. Just one question I had was in terms of training the CIA civilian pilots before this. Who was in charge of that? I mean, to step them up onto higher and higher performance aircraft and not have them kind of hanging around at, just normal Air Force bases. I mean, how was that executed?
That's a really important point. Actually, they're ex-US Air Force pilots, and they were what they call sheep-dipped. So they were kind of given a temporary contract, if you will, with the CIA, and then when they rejoined the Air Force, a review of their records would show actually continuous service within the US Air Force. So they're kind of like airbrushed out the grey bit of their service career. And they were all very, very experienced pilots, as I say, with Mel Vorvadich and all of them. Frank Murray, very, very experienced F-101 pilot. Yeah, I mean, they were at the top of the mountain. And they had to go through absolute rigorous procedures before being allowed to join the program. Being put in a box for hours on end. The medical, which was conducted down in New Mexico, was almost an autopsy. I mean, the guys were saying it went on for a week. And they had to carry this bag around with them in which every bodily fluid for that week was taken from them and analysed. I mean, it was absolutely, they called it actually the astronauts medical.
Another question back here, sir.
Was I right in hearing that you said the program only lasted for 12 months?
That was the Black Shield element of it. No, the aeroplane first flew in 62, in April of 62. it took, although the aeroplane first flew in '62, it took 23 flights actually to get the thing from supersonic up to Mach 3. For the first few months, there were all sorts of problems with the engines, so the prototype seen there was actually flown with a couple of J-75 engines in it instead of J-58s. So yeah, it took a while getting there, and then of course, as I say, there was all this sort of prevarication from 1964 onwards of, well, now we've got it, what are we going to do with it?
So it only it's only really operational was that black shield. That was it. That's all it did.
Absolutely right, yeah, operationally, yeah. That said, though, of course, you know, it was right at the ragged edge of technology then, and it paved the way, as I say, you know, really for the SR-71 that came after it. You know, so much of the information that it gathered was readily available by crews that flew that aeroplane.
And do you know the cost of that program?
Oh, yes, now, that's a good one. It's in the book. Plug,
I'll buy the book.
plug. And it was a lot more than the cost of the book. It was something like, in today's money, I want to say something like $6 billion.
Okay.
I've
got one more, if I may.
Yeah.
What size negatives did those cameras produce?
Okay, that is also a good question. I want to say something like 20 inches by 8, something like that. It was a swathe, and it literally the camera like scanned across the negative.
Okay, thank you very much.
Sir, did I see a question back here or over here? Right here in the middle, yeah.
Gosh, as a precursor to my question, that size negative and 5,000 feet of it being held in the bays, that's phenomenal.
It's a phenomenal. I mean, the negative itself was extra thin, and it went across a scan head so that it wasn't moving around, sort of thing. It went from one side of the airplane to the other, crosswise, from opposite sides. So it kept the center of gravity of the airplane, you know, in the same position. So, but yeah, a lot of film.
The question I was going to ask you was, clearly it was early days for countermeasures, but were there any countermeasures available to the pilot if he were to detect that missiles were coming at him? I presume maneuvers were out of the question because you must have been operating at the limits of stall and flame out and all that, that sort of speed.
Yeah, I mean, it wasn't like the U2, as Chris here would tell you. I mean, you know, this thing was really hacking along at a rate of knots. So, you know, going into the coffin corner on a turn, that really didn't enter into it for this thing. Although, of course, it was a low-G airplane. It wasn't built to turn and burn. But countermeasure, no, I mean, it was the DEF system, really, that it relied upon. In the cockpit, there was a RAeS system, a radar homing and warning system that would be triggered. And there were some lights underneath the cockpit coving that would illuminate. And green would show, perhaps to the left, that the aeroplane was being painted by radar off to sort of the left quadrant. And then you'd hope, according to one of the pilots, that everything worked. I mean, it was done automatically. They didn't have to throw switches or anything. So, you know, they just hoped. I mean, there was a manual override. If nothing happened, you know, pressed this manual man jam, it was actually labeled in the cockpit, and you just hoped that it worked. But, you know, that was it. You could not take evasive maneuvers in this airplane.
Another question. Kit. Yes, sir.
Sorry, can I just add? I said you couldn't take. When I said, people get the impression of putting it into a hard turn and stuff like that. No, you couldn't do that. All actually that you would have to do, and what SR-71 crews would do, was actually increase the throttles a little bit by about 1/10 of a Mach. Take maybe a 10 or 20 degree change in heading and climb a little bit, and that would be enough to actually completely throw the intercept solution for the missile, because of course it was being fired up. This aeroplane is hacking along in the sky. The higher that the missile got, the less control they had over it, because the air was getting so thin. Quite small controlling wings, if you like, fins on the SA-2 especially. So, you know, yeah, you were pretty well in a reasonable place. When the SR was flying, it has had a number of missiles fired at it, nothing like the barrage that Sullivan had to put up with. But again, that was pretty well standard procedure. You know, the jammers would come on, and if it still didn't look good, then a slight change in heading, a slight increase in altitude, and a slight increase in speed, and that would do it. I mean, the aeroplane was built to fly at a sustained speed of Mach 3.2. That was at when the inlets and everything else were at their most efficient. The aeroplane could fly faster if it was in colder air. So it had a compressor inlet temperature red line at 426 degrees centigrade. And the problem was that the temperature rising through the engine was exponential. So like for every extra degree C that compressor inlet temperature rose, the temperature at the back end went up quite considerably. So there was always a danger of, if you flew too fast, even if the outside temperature allowed you to get up to that speed and stay within those parameters, that you could cause damage. There are a couple of people that I've met that have said they've taken the aeroplane up to 3.4, but at 3.5, the engine started, you know, you could do damage, and in fact, anything over 3.4, the engine would be pulled and would have to undergo a thorough investigation for any possible damage. I hope that answers your question.
Okay.
Could the sonic bang from the aircraft reach the ground when it was at altitude? And if it could, what did the effect of the bang have on the people in the overflown countries?
That's a really good question, Kit. So, not perhaps so much for this program, but again, for the SR-71 program, certainly there's a small town on the extended scent line of Beale, and you, Bob, having lived there at Beale for a number of years, will know, Beatty. And when the aeroplanes, the SR-71s were taken off from Beale and were accelerating hard, the village of, or the town of Beatty took a right battering from sonic booms. And it was a triple boom that would hit the ground. And actually, during the Vietnam War, it's quite interesting, 2 missions were flown where 4 SR-71s got airborne out of Kadena. One was an air spare because the mission was so important, and they were timed to fly over Hanoi at stacked altitudes at different levels, so that the triple bang from 3 aircraft were heard by the POWs in the prison camp in North Vietnam, to give them hope and as a message to them that, you know, we know where you are, but we've got your back, we're doing what we can. So it was a kind of signaling, and that happened for on 2 occasions. So yeah, that bang certainly hit the ground, and you know, and it was a signal on that case for occasion for POWs.
Could I ask another one?
Yeah, sure.
When I was looking at the SR-71 in the Washington Aerospace Museum, somebody there was telling me that there were real problems with fuel leaks when the aircraft slowed down and got cooler. Is that correct?
Yeah, it is. When it's quite interesting. The first time I was privileged to amble around one when it was operational at Milton Hall, and the hangar. I mean, the stuff was just dripping. You know, I mean, not just dripping, like a proper small like tap would be coming out of this stuff, and a great pool on the floor. And my escort officer, Barry McKean, who was the deck commander at that time, he said, "Oh, do you want to throw a lighted match on it, Paul?" I said, "You crazy?" It had a very, very high flash point, and so it wouldn't ignite to the extent that normal fuel igniter, normal spark plugs in the engine, if you like, were incapable of generating enough temperature to light the fuel. So it had to have a chemical ignition system to ignite the fuel. And so it goes on. Virtually everything on that aeroplane was scratch built. I mean, Kelly Johnson and his design team were just incredible. When you bear in mind that they pretty well had just a slide rule. I mean, computers, in the late 50s were absolutely in their infancy. But you look at the shape of it even today. If you go to Duxford and take a look at that aeroplane, I still can't really get my head around how something that looks so futuristic pretty well first flew, the direct descendant, in 1962. Incredible. But yeah, so as the aeroplane expanded, and I've had different conversations with people, a chap I was very privileged to meet and spend a couple of days with, Ben Rich, who was the chief thermodynamicist on the aeroplane, and later he was Kelly Johnson's protege, and took over running the Skunk Works. Said, yeah, there's a lot of, some people say 4 inches, some people say 9 inches that the airplane expanded by. He said, but you know what, Paul? There's nowhere up there with a tape measure to measure it.
Chris, did you have a question? I see the other hands. I won't forget you, I promise.
Paul, the A-12 compared with the SR-71,
Sorry, Chris.
you mentioned the imaging radar. What about some of the other differences? And in your opinion, was that the only reason for the retirement of the A-12, or did bureaucratic considerations intervene and interagency disputes between the CIA and the Air Force?
Okay, it's a good question again, Chris. So, the main reason for the aeroplane being taken out of service when it was, excuse me, because of the Bureau of the Budget, the beanies, the good old accountants, even back then. And it was a case of, well, why have we got a covert aeroplane and we have CIA, and why have we got an overt US Air Force aeroplane doing pretty much the same job? And, money was getting tight. There was other things. There's always money, other programs and projects that needed money. And so really it was something that the Bureau of Budget were the people that really brought that debate to the fore. And as well, you could see there that it was kind of gathering tactical reconnaissance. It was never really meant to do the job it was doing in North Vietnam. It was designed to fly over the Soviet Union to replace the U-2 doing that job, which it never did. So, arguably, was it really doing the right job when it was out in Vietnam? Oh, yeah, well, the big external difference is, of course, you had an extra seat. So where the camera was in the A-12, the Q bay, that's where the RSO, the reconnaissance systems officer, sat, actually helping to take some of the burden of the workload off the pilot. That was certainly, one of the biggest external differences. It made it heavier, of course, so therefore it couldn't fly quite as high as the A-12. But yeah, they're really the main differences. I mean, the SR-71, with its improved sensor package, really did collect, provided a synoptic coverage. I think one of the frustrating things about the whole thing was that the SR-71 had the ability to use real-time or near real-time reconnaissance with the advent of digital cameras and obviously the radar data could actually be sent up to a satellite and bounced down to commanders in the field. And it was there, but for different reasons entirely, which were political, I would say. The fighter mafia, as it was known, that was running and pulling the purse strings at the Pentagon, just weren't having it. They wanted it buried. They were converts to satellites and wanting to use the money that the SR-71 program was using on other things. So to my mind, the airplane, the SR-71, was retired 5 years early, I would say, than it should have been. It's interesting because within about a year of the airplane finally retiring, Gulf War I kicked off. And Schwarzkopf, I mean, that war was absolutely an incredible, you know, way of how to fight a war, really. But Schwarzkopf was not overly impressed at the level of aerial reconnaissance coverage that he was getting. You had RF-4Cs kicking around Vietnam, having to go around and take pictures. Indeed, a friend of mine, an ex-SR-71 pilot, when the program was chopped, found himself flying EF-111 jammers over the desert to protect RF-4Cs taking the pictures. And he said, you know, this is just crazy, you know. It took countless RF-4C missions to do what the SR could do in one sortie. There you go.
I think we have time for at least one more, and this gentleman here has been very patient. Thank you.
Thank you very much. That was a fantastic presentation. Thank you so much.
Thank you.
I noticed that the tracks were not all straight lines, they were quite long curves. How is the camera thing used? Would it take pictures through the turns as well, or was it purely on the straight and level runs?
No, they were good question. They were very gentle turns, very gentle turns. The camera itself could be caged or uncaged. If it was uncaged, then literally it was kind of bolted, if you like, to the roof, so that it would stay, you know, horizontal as the airplane kind of, if you like, banked around it. So there was that ability to do that. What, the aeroplane? Oh, the camera. You know, I really do not know how many degrees of bank the camera was able to take. I really don't. But as I say, the aeroplane in and of itself, again, I have to go back to like the SR-71 data because I've read through the flight manual a few times. That's how sad I am. But you would look at something like a 35-degree bank turn as a maximum, really, you know, about 35 degrees. So they were, in all intents and purposes, you know, quite gentle turns. It was a low Q airframe.
I believe the gentleman in the green shirt has been super patient for us. So with everyone's indulgence, this will be our last question for now, but Paul will be available upstairs to answer more questions and sign books. Sir, go ahead.
Thank you for a very interesting talk. I had a question. You mentioned sort of its first public appearance when it was deployed. I was wondering maybe if you could comment a bit more on what sort of the public knew at that time when it finally was deployed and what the sort of perception was.
Yeah, that's again a very good question. So, you know, the aeroplane operating out of Area 51 was just surrounded by desert, you know, and there was a very tight security cordon, you know, stretched out miles and miles away from the airfield, so making it very difficult for anyone to really see what was going on the airfield. When it went to Kadena, though, however, there was a hill just outside of the airfield, and in fact it came to be known as Habu Hill, where you get lots of spotters with telephoto lenses and other people who had other reasons to want to be there and do different things with their pictures, taking pictures of the airplane. What you did have, and you're quite right, is people were starting to see the airplane despite this. Airline pilots quite incredulously seeing something like that, you know, flying along every now and again. There was a case of an aeroplane, even during the Black Shield missions. Frank Murray had to divert into Tac-Lee, which of course is an airfield, a US Air Force base, and he had an engine go on him, and he managed to recover into Tac-Lee it's quite funny actually, if you don't mind, I'm coming off a bit here. So he landed unannounced. The controllers was shouting at him for, wanting to find out who he was, and he would say, U.S. Air Force single jet, and he landed and dropped the drag chute, which is standard operating procedure, on the runway, taxied off and just sat there with the engine running, dropping the drag suit, screwed up an F-105 launch completely, and there he sat asking for the base commander to come out because he had certain things to tell him, what can do and what couldn't. And he said, and while he was there were people coming out, Air Force people, from all over the show, taking pictures of this aeroplane. And he said security had an absolute field day afterwards, confiscating film. And they did well because, to this day, I still not have, there must be someone out there, who's got a picture of Frank Murray's aeroplane, sitting in TAC Lee. But yeah, as yet it's not surfaced.
Ladies and gentlemen, before I turn this over to Howard for one final announcement, Paul, I wanted to make sure you knew I had to wear a necktie this evening, and geez, I'm never going to do that again. So we decided that in honor of see, that's what neckties do. In honor of your presentation, we'd like you to wear a necktie next time. So thank you very much. We can take the plastic off.
You do? Okay.
Thanks, Robert, and thanks, Paul, for a fascinating exposition. I mentioned it to him at the start. I was looking underneath one of these beasts for scale modelling purposes. And when they're cold, you can actually see the air gap between the longitudinal bits of metal in the wing, because it only works when it expands. That's why they leak. Okay, I hope you've enjoyed that. On behalf of the Heritage Specialist Group, I'd encourage you, if you haven't already, to tick heritage in your profile on your society membership. That way you'll join part of the 3,000 people that we try and communicate with fairly regularly on heritage matters. We're also about to launch a LinkedIn group which you can join to participate more in the work of the committee. So as we expand beyond the Journal of Aeronautical History, we're trying to link in lots more definitive, authoritative heritage information that you can use for your own benefit, disseminate in your companies, help people to understand the heritage of the industry that we represent, because it's an inspiration for the future, and that's what we're trying to achieve. So Paul, thank you very much indeed, and we will